This lesson is about forming compounds, and the learning target is to be able to give the chemical formula and name of ionic and covalent compounds. And this video is specifically going to work on finding the chemical formula for these compounds made by two different elements. So when we're doing this for covalent compounds, we're going to focus more on just drawing the structure of these. I could give you for this first one, we could go maybe what's the compound form from phosphorus and hydrogen, but you're never actually, it's not a lot going to have to do that. And so we'll just work on drawing the Lewis structures of these compounds when we have these. So if I have a compound like this, remember these covalent compounds are sharing electrons, they're not transferring them. And so we draw these a little bit differently. My phosphorus is 1, 2, 3, 4, 5 electrons. My hydrogens have one valence electron apiece. And I drew them off to the left side. It doesn't really matter where I drew them because I know there's one. I just want them facing this phosphorus. Now, you can see over here that my phosphorus is going to try to gain 3 electrons. It has 5. It's going to try to gain 3 electrons. My hydrogen has a choice here. Now, hydrogen is a little bit funky. It can either lose the 1 electron or it could try to gain another one to form a full outer shell. And so hydrogen is not really picky about what it does. It will form an ion sometimes, but it will also form covalent compounds through sharing electrons and gain one and have 2. So you can see that I've got my 1 unpaired electron here. These 2 electrons we consider paired, and they're really not going to be involved in any bonding here for our covalent compounds. They're really going to stick to themselves. I don't know, you could say they're paired up, they're happy. That's a lesson for a different story, but just focus on the unpaired electrons. You can see that I've got 3 unpaired electrons on phosphorus, and so one of these unpaired electrons is going to go over and share with this hydrogen over here. So this electron is being shared with this hydrogen, and this electron is being shared with this phosphorus. Now the hydrogen has 2 electrons to fill its shell, and our phosphorus has 1 more. And so we repeat that process with this phosphorus. It's going to share an electron here, and then this phosphorus is going to do the same thing with this hydrogen here. And so what we end up having here is our phosphorus has 1, 2, 3, 4, 5, 6, 7, 8 electrons around it. It has fulfilled its octet in that way by sharing because it's using all of these electrons. And our hydrogens each have their 2 electrons around themselves, and so they are stable. And so this is how we would draw the Lewis structure, the compound, the molecule for phosphorus trihydride. And we would also draw it this way. So see how these 2 are paired up? That's a pair of electrons, and they're being shared by both the phosphorus and the hydrogen. A lot of times we will show that with just these little sticks here to show that structure there. And leave our 2 pairs of electrons there. So this is the Lewis structure for phosphorus trihydride, which we'll learn how to name in a bit. So let's get this one, CCl4. My carbon is 1, 2, 3, 4. My chlorine again has 1, 2, 3, 4, 5, 6, 7. And I'm just going to draw one of these just to save some time here. And so you can see that carbon's going to be trying to find 4 electrons to make pairs with. Again, carbon doesn't really form ions. It's not going to gain or lose 4 electrons just outright. It's going to more try to share one of its own with another atom while getting 1 electron from that other atom. And so that's what's going to happen here with chlorine, because you can see that chlorine has 1 unpaired electron that is going trying to share here. Right, so that same exact thing is going to happen for each of these unpaired electrons that carbon has here. These ones are going to share. You can tell we have 4 carbons or chlorines, and so what we're going to end up having here is this right here, carbon tetrachloride. Another way that we can show it is Cl, 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 Cl. And if we wanted to go back and track, whose electrons were whose, the red ones you could think of as the chlorines, the black ones you could think of as the carbons, And so each atom is contributing one electron to the pair, but they're all using them in the same, and then you'd have your extra electrons around here. So this would be the structure for carbon tetrachloride, CCl4, right? And so we have, let's go to another one, H2S. Get rid of this right here. So we look at H2S. H has one valence electron. H has one valence electron. Whoops, that's a C, not even close to what we're trying to draw. We're looking for an S. 2, 3, 4, 5, 6. Again, Lewis structures are important. This one unpaired is going to pair with that unpaired. This one and this one are going to pair. This will be like with S, H2. This would be the structure for H2S right here. We'd have one pair between S and H, and then sulfur would still have its other electrons. So let's look at carbon dioxide here. Carbon, 1, 2, 3, 4, and we've got oxygen, 1, 2, 3, 4, 5, 6 valence electrons, and we've got our oxygen, 1, 2, 3, 4, 5, 6 valence electrons. So our oxygen here, again, is going to be trying to find 2 electrons. Right? Both of these 2 oxygens are going to be trying to find 2 electrons. Our carbon is going to be trying to find 4 electrons. And so each of these unpaired, this is why the unpaired electrons are important here. We've got 2 unpaired electrons for each of our oxygens, which are going to be shared amongst our carbon in exchange for one of carbon's electrons. Again, they're being shared, not transferred. And the same thing is going to happen with these ones down here, right this way. And so this is something called a double bond. Carbon is giving up 2 electrons. Carbon is going to share 2 electrons with the oxygen, and oxygen is going to be sharing 2 electrons with the carbon. And so what our structure looks like here is if we were going to draw this out and show all of the electrons, this would look something like carbon, 1, 2, 3, 4, oxygen, and then oxygen would have its other electrons here. And you can see how oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons that it's using. Oh man, there's a lot of dots here. Carbon would have the same 8 electrons it's using, and oxygen would have 8 electrons over here that it would be using. A way that we can show this, and the way that you will see it, is called a double bond here. And so this is the way to show that the way that the electrons are being shared between these atoms. And so I always think of these lines as being dot, dot, electron, 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 electron. But that would be the Lewis structure for these covalent compounds. And so those are more about drawing, and we'll get to how to name these covalent compounds in the next video. But I hope this one helps with the ionic. Again, start with the ions, then do the crisscross method to find the chemical formula. And then with the covalent compounds, we're looking at how many electrons are they going to be trying to share here as we figure out the chemical formula.